So, welcome back to WAPSI. So, we can move to another section of magnetostatics. Okay, the first question is the horizontal component of Earth's magnetic field at a place is 3 into 10 raised to minus 5 Tesla. That means the horizontal component, not the exact magnetic field. Okay, if the dip at the place is 45 degree, okay, the resultant magnetic field at that place is, so actually the theta is, see, the theta is 45 degree, and what is 3 into 10 raised to minus 5 is horizontal component. Okay, so B is actually BH into cos theta, because horizontal component, when we draw a triangle, the horizontal component is cos theta, because cos theta is the related to adjacent side. Okay, so if we draw a triangle and this is the theta, the horizontal component is this. Okay, this is the horizontal component and this is the vertical component. Okay, then this side is dealing with the adjacent side of the angle theta. Okay, the adjacent side is what? Cos theta. Cos theta is nothing but the ratio between hypotenuse and the adjacent side. Okay, so horizontal component of BH is 3 into 10 raised to minus 5. So BH is equal to, that means the magnetic field of Earth is equal to B divided by cos theta. And what is theta? 45. So what cos 45 is 1 by root 2. So B into root 2 is the value. So BH is equal to, actually what is the value of B? B is 3 into 10 raised to minus 5. Therefore 3 into 10 raised to minus 5 is multiplied by root 2, which is equal to 3 root 2 into 10 raised to minus 5. So that is option B, 3 root 2 into 10 raised to minus 5 Tesla. Okay, so we can move to the next question, the second one. The second one is, in an atom, electron revolve around the nucleus along a path of radius. Okay, the radius is given, r is equal to 0.72 angstrom. Okay, making 9.4 into 10 raised to 18 revolutions per second. Revolutions per second means what? Frequency. Okay, frequency is given 9.4 into 10 raised to 18. The equivalent current is, we have to find the current, and they have given the charge. Actually current is what? Rate of change of charge. That means how much amount of charge is moving in a unit time. Okay, that means charge divided by the time period is the current. So which is equal to charge into frequency. See, both are given. The frequency is given and the charge is given. Just multiply. Current is equal to charge is, and we don't want the radius. Okay, and the current is equal to 9.4 into 10 raised to 18, which is the frequency, and the charge is 1.6 into 10 raised to minus 19, which is equal to 9.4 is multiplied by 1.6 is multiplied by 10 raised to minus 1, which is 15 into 10 raised to minus 1, which is equal to 1.5. Yes, 1.5 ampere is our answer. Okay, which option is the correct one? Option D, option 4 is the correct answer. Okay, so we can move to next question. A solenoid of length 50 centimeter. Okay, length is 15 centimeter, L is equal to 50 centimeter, having 100 turns, so N is equal to 100, carries a current of 2.5, so I is equal to 2.5 ampere. The magnetic field at one end of the solenoid is, actually each and every turns, these 100 turns will contribute the magnetic field. So the magnetic field at one end of the solenoid is given by the equation B is equal to, which equation? B is equal to mu 0 ni by 2 into length, or mu 0 small ni by 2. Okay, here small n is the number of turns in per unit length. Okay, they have given 100 turns in 50 centimeter. So 200 turns in 1 meter. So in unit time, sorry, unit length, there is 200 of turns. So B is equal to mu 0 into 200 into current is what? 2.5 divided by 2, which is equal to mu 0 into 100 into 2.5 is 250. Okay, B is equal to 250 times mu 0, and the value of mu 0 is equal to 4 pi into 10 raised to minus 7, or mu 0 is equal to 1.257 into 10 raised to minus 6. Both are correct. Okay, we can use the second one, which is equal to 1.257 into 10 raised to minus 6 is just multiplied by 250. Okay, which is equal to 1.25 into 25 is 25 plus 25 by 4, which is 6 plus 25 is 31, approximately 31. Yes, 31. 25 plus 25 means 1 by 4. Yes, that's why I add 25 by 4 plus 25. Yes. So into 10 raised to minus 5, which is equal to 3.1 into 10 raised to minus 4. We can check with our options. Okay, 3.14 into 10 raised to minus 4 Tesla is given as the third option. Third option is the correct one. Okay, so we can move to the next question. Fourth, which of the following statement proves that Earth has magnetic field? See, Earth has already magnetic field, and which statement is related to that? Earth is surrounded by ionosphere. A large quantity of iron ore is found in the Earth. The intensity of cosmic rays stream of charged particle is more at the poles than at the equator. Earth is a planet rotating about the north-south axis. Okay, the Earth is surrounded by ionosphere, yes, but it needs more clarity. A large quantity of iron ore, that's is the second option is doesn't make any sense. The intensity of cosmic ray stream of charged particle is more at the poles than at the equator. See, this is a shape of Earth, and the magnetic field is lying like this. See, the intensity of the magnetic field is more in poles than in equator. Okay, so in poles, due to this high intensity of the magnetic field, the cosmic rays, it can capture the cosmic rays stream charged particles. So it can stream a charged particle. So that's why we are able to see a greenish light. We are able to see a greenish light in the ionosphere. Okay, in the poles. So option 3 is the correct one. So we can move to the fifth question. A magnetic field of flux density is given normal to a 18 turn coil. Okay, N is given of area is 0.01 meters square. Okay, if this coil is removed from the field in 0.2 seconds, so dt is given 0.2 seconds. The EMF induced in it, so EMF induced is d phi by dt. Okay, so what is the flux in the initial time? Here the flux density is given. Okay, flux density means for one coil for a unit area. Okay, here the area is 0.01 meter square. So per unit area we have the 1 Weber per, so that is multiplied by 0.01. So the flux is equal to magnetic field density is 1, that is multiplied by the area 0.01, that means the contribution of magnetic flux to that particular area, into 80 total magnetic flux, which is equal to 0.1 into 8 is 0.8. Yes, final flux is 0.8. Sorry, the initial flux is 0.8 and the final flux is 0. So 0 minus 0.8 flux change, minus of 0 minus 0.8 in 0.2 seconds. So 8 by 2 is 4 volt, because we know that epsilon is minus d phi by dt, so that's why I put a minus in the outside, and the final flux is 0 and the initial flux is 0.8. So 0 minus 0.8 is minus 0.8 and minus of minus is plus, so 0.8 by 0.2 is 4 volt. So I think you understand the concept, and we have the main formula in here. The EMF is generator is proportional to minus d phi by dt, and the flux is given. Okay, we have to find the flux for our given area. Okay, flux density is given, so we have to find the flux for our given area and multiplied by the number of coils. Okay, so we can move to the 6th question. A long solenoid have 500 turns, so total 500 turns is there. When a current of 2 ampere is passed through it. Okay, so I is 2 ampere and capital N is 500 turns. Okay, the resulting magnetic flux linked with each turn of the solenoid is, okay, so the magnetic flux phi with each coil is 4 into 10 raised to minus 3 Weber. Okay, then the self induction of the solenoid. Okay, we have to find the self induction, since the Li is which gives total flux. Okay, what is the flux in here? 4 into 10 raised to minus 3. Okay, which is equal to 4 into 10 raised to minus 3 is multiplied by 500, because there is 500 turns, and phi is given for, see, 4 into 10 raised to minus 3 is given for each turn. So how many turns are there? 500 turns. So the total flux is 4 into 500 is 2000. 2000 into 2000 into 10 raised to minus 2 is 2. So L is equal to 2 by I. What is I in here? I is current is 2 ampere. So divided by 2 by 2. Okay, I is 2 in here, so 2 by 2, which is equal to 1 Henry. Okay, 1 Henry. Option B is the correct answer. So in here the main important thing is Li is equal to total flux. Okay. Okay, moving to the 7th question. A metallic rod of mass unit length 0.5 kilogram per meter. Okay, metallic rod of mass per unit length, that is 0.5 kilogram per meter. Okay, is lying horizontally on smooth inclined plane. Okay, so this can be the inclined plane. Okay, which makes an angle 30 degree. So this will be 30 degree with the horizontal. A magnetic field of strength 0.25 is acting on it in the vertical direction. Okay, so this can be the rod. Okay, and in vertical direction a magnetic field is applied. Okay, when a current T is, okay, we cannot add that as I, is flowing through it, the rod is not allowed to slide down. Okay, actually there is a force acting on the rod into the lower part. Okay, and the quantity of current required to keep the rod stationary, that means we want to make the rod as in a stationary position. Okay, so this will be the direction of mg, that means the normal gravitational force. Okay, and we want to calculate this hypotenuse, and we have this opposite side. Okay, so we can take the sine function. So mg sine theta, we have the mg sine theta, and the magnetic field is in this direction, and this angle is what? This angle is 60 degree, because this angle is 30 degree, so that angle is 60 degree, and we have the force due to the current and the magnetic field in this direction. Then only the particle will stay there, okay, without any motion. Okay, so here we want a force on the adjacent side, okay, which is equal to, by the magnetic field, B I, magnetic field into current into L, VIL, and here we have the angle theta 60 degree, and we want the adjacent side. So which trigonometric equation which gives the adjacent is the cos theta. So VIL cos theta. And what we want actually we want the current. So I is equal to BL mg sin theta divided by BL cos theta, which is equal to mg by BL into tan theta. Theta is 30. So the current I is equal to M is 0.5 and G is 10, and what is the magnetic field? 0.25 multiplied by L. L is unit length. So 1 into tan theta. Tan theta is 1 by 2 divided by root 3 by 2, which is 1 by root 3. Okay, so which gives 5 by 0.25, which is equal to 20 by root 3. Okay, actually we want to calculate the 20 by root 3. Value of root 3 is 1.71. So 20 by 1.71 is how much? It is approximately greater than 10. Okay, we have two options, which is greater than 1. So 1.7 into 14, yes, 20 divided by 1.7. Okay, then the answer must be 20 divided by 1.5, which gives approximately 115 or 50. So remainder 5. Okay, 0, 5, 3, 1.3. 20 divided by 15 is 1.3. So 20 divided by 1.7 is less than 20 divided by 1.7 is less than 1.13, which is less than 13, which is only the answer 11.32. Okay, so we can move to the 8th question. A physical quantity which is measured in the unit of Weber per ampere. Okay, so the unit is per ampere, Weber per ampere. So we need to know what are the equation for self-inductance, mutual inductance. For the self-inductance, we know that L is proportional to N5 by I. Okay, so inverse of current. So this is correct. For this one, mutual inductance also, M di by dt is proportional to a constant. So M is inversely proportional to current. So for the mutual inductance is also correct. A inverse, that means current inverse. And the magnetic flux is given as BA cos theta. That means the flux is directly proportional to the magnetic field B, and B is directly proportional to the current. So A inverse will not happen in the magnetic flux. Okay, because a magnetic flux is directly proportional to A, not A inverse. So this one is incorrect. So both A and B are correct. Option D is both A and B. Okay, bye. See you later.